All right, dude, we are live. What's up, guys? This is Dem Keys, and today we are gonna be, hopefully, we're gonna be finishing um, TOML. That's what I was looking for. Um, Hopefully, today we're gonna be finishing learning TOML, and we're gonna be graduating TOML, so to speak. Um, yeah, dude. So between yesterday and today, I did not actually play any games. I kind of wanted to continue, with this research and make some progress on this front. And if I would have started up the game, then I would have just gotten, absorbed into it. I might play it today though. I'll try to keep a limit on that, but I might play it today though. I have to decide if I want to do Metro or Stardew Valley because I equally want to play both of those games because they're both interesting in their own right. But yeah, let me see how I want to approach that. Um, Yesterday I was doing a bit of research. I was chatting with Gemini. So hold on, let me come back here. So I was chatting with Gemini about the whole TOML being serialized to JSON thing. And I was like, okay, hold on. Why is it that I need to, let's say I have, um, I guess we can close this. I don't need to have this open. Yeah. Let's say I have this kind of TOML, right? Um, Considering that this is going to be divided up into dictionaries and stuff, why is it that I have to create a very complex hierarchy of structs or of types? I guess I mean same thing, right? Is it the same thing though? I need to see if it is possible for if it is words. Holy shit! I need to see if it's possible to use enums to do this though, because I've been like in terms of custom structs for deserializing TOML into a Rust object, not necessarily JSON, but like a Rust object, um, an object an object that you can use within your Rust code itself. In terms of doing that, I have mainly only explored the custom structs route. There was another route as well, I believe. Hash map. Hash map was one route as well, and I think there was one more route that Gemini had told me about, and I can't remember what the route was. But hash map was definitely one of them. The thing is, even with hash map, really, what you're expecting, like you would need to create a hierarchy within the hash map itself, and I feel like that can get really complicated very quickly. If you have like a very simple key value pair kind of thing like this, as long as it's something like this and it's all being converted to um I don't know if I can use dyn for the value though, because I just remembered that, okay, this first one is going to be the string, right? Second one is going to be an integer, so that's not going to be in double quotes. That's not going to be a string. Um, that's going to be a separate type. The date, I believe, becomes a string as well. I don't think it deserializes to some sort of concrete date time type. I don't even know if Rust has its own concrete date time type. I'm sure that there must be like, you know, some functionality to, I mean, within the standard library, maybe they've provided something, but I mean, just concrete data type. That's what I mean. I don't think that's a thing when it comes to date time. I should look into that though. I should look into that because I can see it being a thing where maybe they set it up as a struct, and the struct has various methods and fields and stuff like that. But if we are talking about something like int or a string slice or a byte or something like that. I don't think out of the box. Hold on. Let's, is that a thing here? Because I can see it being a thing with, hold on, what's going on? Oh, I can see it being a thing as a struct. Right, so there's a date. Oh, this is from TOML. That is not what I was looking for. Date time. Oh, interesting. Okay, you know what? I'm not gonna dive deep into that right now because that'll then become another distraction, which is gonna take me away from this. Back to what I was talking about. What I was saying was sorry, zoned out. What I was saying was um what was I what words? Holy shit. What was I saying? I can't remember what I was saying. Well, anyways, I was having a conversation with Gemini trying to understand this whole thing about like, why I have to create my own custom structs, whereas in the JSON crate, the CRD JSON crate and in the TOML crate, there seems to be a value type that I can pass in, which you can see here on this line. I tested the thing out, and dude, one of these days, I want to sit down and explore the the generics system in Rust, which makes the need for which brings about the need um for the silver shit. Oh my god, I was about to say silver shit, which brings about the need for the silverfish. It's not even silverfish. Why did I say silver? The turbofish syntax. I need to explore. Um, in fact, okay, it's not even the need for the turbofish syntax. The turbofish syntax can be used to solve the problem that is being created, and the problem that's being created is the fact that the compiler can't figure out what the it can't infer the type. A lot of the times, the compiler is great at inferring types, which is why you often don't need to, specify what the type of something is going to be. So that's why I can create something like a equals 5, and it can infer that it's I32, so 32-bit integer. Or I could create um, what's a good way to do a byte? If I do in binary, I think it's still going to store it as an integer, right? Yeah. What's a good way to do it as a byte? Because if I do it as hex, that's still going to be an integer. Oh, U8, U8. Yeah. It was hold on. So we can do 5 underscore U8. And now we have um a byte. And in fact, an unsigned byte. That's wait, if U8 is unsigned byte, what is signed byte? Is it S8? No. What is, oh, is it I8? Oh, it's I8. Okay. That's a signed byte. And then I guess, yeah, unsigned, we can also have unsigned 32-bit integers and 16-bit integers and stuff like that. Yeah, U16. But yeah. Where was I going with it? Oh, yeah. So usually the compiler is great at inferring types. Sorry, zoned out. Usually the compiler is great at inferring types, but because of Rust's very powerful generic system, which lets you create very sophisticated behaviors and very sophisticated types, you can end up in situations where the compiler doesn't really know what the type is supposed to be, or, well, the second thing I was about to say is what actually leads to the compiler not really knowing. Like, okay, in general, the compiler might not be able to figure out what the type is, but also there might be a situation where a certain type has been made specifically for you to provide, you know, your own type there. And so whatever type you pass in up the chain, for lack of a better term, that type is what's going to be propagated throughout the entire generic type. So any trait that the generic type is implementing, that's also going to be using the concrete type that you passed in. Any functions that this trait or just the struct, the generic struct implements, they're also going to be using the concrete type. And that's actually not a good example of why. I think one of the situations where you end up needing this is when you have multiple generic types and then the type that's being returned is not known. I think that's, but okay. So my point is, I one of these days want to really explore. In fact, I did set up a conversation with Gemini, so Gemini can give me an example of that kind of thing, like to try and understand, because I understand what the problem is and what problem the compiler is having that we solve by explicit annotation via explicit annotation. And the explicit annotation can be either, you know, next to the variable name or in the form of the turbofish syntax. um, so I understand what the problem is, but what I'm trying to figure out is what leads to this problem. I'm trying to visualize, not even figure out, I'm trying to visualize how we get to that point. So I want to be able to visualize a scenario where we start at some point and then we are propagating down and we reach to a point where, oh, okay, now at this point, the compiler doesn't know what the type is supposed to be for this. So that's why you have to specify what the type is supposed to be. Though I'm wondering if the situation there could be as simple as like, okay, let's take a look at, hold on. Would it be from str? Yeah. So from str is also a generic function, right? If I remember my generics syntax properly, I'm seeing a lifetime annotation and a generic parameter. Now, this is from str is being implemented on what exactly? Because I believe I'm directly calling it on the module. So in this case, we provide crd JSON value, and internally we hold on. Actually, if I look at the code for this, it's probably going to be um, there was a thing for go to definition, wasn't there? Let me see if I can get the information from that. So here, this goes to deserialize, deserialize. So then the idea here is that the type that you're passing in should implement the deserialized trait and therefore have the deserialized method. And the result of that is then going to be returned by the function. Okay, so if that is the case, no, back up. So S is our string, right? We don't touch the string's type at all. I feel like that's something important to note here. We don't touch the strings type, or we don't lean on the strings type at all, other than for passing it into the parse function. And the parse function also takes a string. So like we have the concrete type already set up there. This is expecting an str or a string slice, not just an str. This is expecting a string slice, and we have the string slice. We pass that string slice into parse, which is also expecting a string slice. Right? There's no type annotation needed here. Here it's just returning self. So it's going to return like an instance of itself. Um, but then in this case, I guess, so the reason why we are using, oh, now I get it. I guess this is one scenario where where words, oh my God. This is one scenario where we are actually able to see why it is required, why the explicit type annotation is required. So this is a generic function that is, or generic method function. This is a generic function that's implemented in the module itself, right? This does not belong to any specific type. Um, so this is a generic function that takes in a generic type. No, it doesn't. No, it doesn't. It returns a generic type. It doesn't take in a generic type. It's taking in a string slice. What it returns is a generic type. The the generic thing, it's not even a generic parameter. The generic type is what's returned later, but also within the function itself. The generic type, um, we're going to be calling something on this type in order to, so does value have, let me check. Does value itself, so let's say CRD JSON, or let's do TOML JSON. Wait, I did from str, right? I've passed in two things. So let's fine. Let's say CRD JSON value. Um, okay, let's create a variable here, and then let's do a dot backup. What is value? Value is an enum, isn't it? How I forgot how you work with enums. Oh, I think it's just like this. So let's do 15, I guess. Okay, then a dot deserialize. So there's a bunch of deserialized methods here. I'm looking for just deserialize, but that's not there. I guess that's not a public method. If it's not a public method, hold on. No. I'm confused about that. Um, dude, wait. I remember saying that we're not going to be. King, hello. Welcome to the stream. Thanks for the follow. I just noticed that you followed 6 minutes ago. Welcome to the stream. Hello. We are doing some Rust studies. more so actually not Rust. We are doing some TOML studies, and I was exploring Rust's generic system, I guess. I'm never really sure what to call it. Rust's generic capabilities, Rust's very sophisticated generics system that lets us build very complex types, but also because of which we have situations where we have to specify the concrete type. Um, so we are here, right? When we pass in a certain type, what we are saying is the type that we pass in. I'm also noticing that it's using this, um, I forgot what they're called, associated functions. It's not using a method. It's not calling a method. So it's like on the type. It's calling it on the type. It's calling it on the type. Hold on. Um, let's say COD JSON value. Oh, there it is. Okay. Damn. But this requires a deserializer. This is not what I'm looking for. Yeah, this is not what I'm looking for. Value deserialize. See, the thing is, I'm not able to figure out if, oh, I'm not able to figure out if deserialize here is being called as an associated function on the value enum, or if it's being called on, or if it's being called as, can you call, hold on, like if I, what is this? Oh, if I do something like let a equals this, and then this is going to be number 15. Can I do something like this? No, that doesn't work. That doesn't work. Yeah, the associated function would be called on the enum itself. There seems to be an issue here. Expected number found I32. Expected number found. I thought this is expecting a value. Am I not supposed to give this a value? What kind of number are you expecting? Oh, okay. Expected value found struct. So we do this, or is it a unit struct? Struct n n. Okay, n 15. Mismatch types. Expected n found integer. Oh god, dude. Field is private. So how are we meant to like use value exactly? Because it says this, right? So I'm I'm expecting to just be able to pass a value into this, but it's not taking the value, right? And then we have this number. It apparently it takes this, but then I'm not able to use this either. How am I meant to use this? Oh, is it through this? Let's try something. From, why does it only have these big these big numbers. Okay, sure. Let's do that. Um, Now let's pass 15 here, and oh God, dude, I'm not able to reproduce this. Let me ask Gemini. Hey, I'm learning to use the CRD JSON crate. I created um, a value object or a value instance, let's say. But well, value instance using CRD underscore JSON value um, this. But within value, we need to pass in, value number. But within number, we need to pass in something which I'm not able to, uh, I'm not able to figure out. I thought I just had to pass in an integer. Okay, the issue is that Rust is incredibly strict about its types. The number variant doesn't actually take a primitive integer like i32 or u64 or a float directly. Instead, it expects a specific wrapper type called JSON number. Okay, this wrapper exists because JSON numbers can be integers, unsigned integers, or floating point numbers. Oh, is that why we have these three things here, like in the from thing? Yeah, from U128. So floating point numbers, integers, and unsigned integers. Okay, so what does this return? Oh, it's an option, right? How do I, oh, just unwrap? There we go. Yeah. If I would have just looked at the return types, I would have figured the thing out. Okay, why was I doing this in the first place? I at this point I forgot why I was doing this. Yeah, I forgot why I was doing this. Dude, you know what? Let's just there's I've been yapping for a while. I've been yapping for like 28 minutes now. Um, let's use whatever remaining time we have to do some TOML studies. Okay, so um, this is our TOML. Sorry, zoned out. Okay, this is our TOML. Yesterday I was in this section. So we are done with, yeah, let's read the table thing. Okay, tables, also known as hash tables or dictionaries, are collections of key value pairs. They are defined by headers with square brackets on a line by themselves. You can tell headers apart by you can tell headers apart from arrays because arrays are only ever values. Okay. Under that and until the next header or and a file are the key values of that table. Key value pairs within tables are not guaranteed to be in any specific order. Okay. Um, Naming rules for tables are the same as for keys. We read that the last time. We also understood why this is happening because tater.man is within double quotes. It's kind of interesting that we are even able to do this. Um, but yeah, this basically means that uh, it's not going to be three dictionaries. It's not going to be like, dictionary man is inside dictionary tater, which is inside dictionary dog. What we're going to have is dictionary tater dot man inside dictionary dog. And within dictionary tater dot man, we'll have, wait, this is type dot name. How does dot work in this case? I can't remember what the dot does in the case of keys, or in the case of, well, yeah, in the case of keys. Let's go down. Okay, we have dot. Um, Also, apparently, spaces are accepted. White space around dot separated values is ignored. However, it's best practice to not use extraneous white space. That's fair. Okay, what does, wait, where did they start talking about dot? Here. Okay, as long as a key hasn't been directly defined, you may still write to it and to names within it. I didn't get that. Okay, this makes the key fruit into, okay, so then this makes key fruit into a dictionary. But then isn't apple also a dictionary then? Like let's try this. Okay. Fruit dot apple dot um smooth equals true. Wrong, true. Okay, so I have to bring it down myself. All right. Hold on. So if that's the case, what is it? Smooth equals true. Right. So this is done. Let's run this, and it says fruit. Also, the order is not. Yeah, the order, it did mention the order is not determined, right? The order is not like fixed. Yeah, I think it did mention. I mean, aside from in tables, uh, outside of that also, the order of things is not fixed. So that's why we are now seeing fruit up, name, then sum o one, then table o one. But okay, I guess this answers my question. Smooth becomes a key with a value, which is inside the apple table, and the apple table is inside the fruit table or the fruit dictionary. And apple is also a dictionary. All right. Um, then is that all I was looking for in terms of the dot notation or the dot thing? Okay, as long as a key hasn't been directly defined, you may still write to it and to names within it. Okay, so then you can add to the table fruit like so. Wait, all right, let's say fruit dot orange equals 2. This is this is the I forgot what the plugin was called. This is a plugin that wait, um, this is a plugin that visualizes colors, and it has certain triggers. Like if you have what do you call it? If you have hash followed by a bunch of different colors, there's a 3-digit color thing, 4-digit color thing as well. Like I haven't fully understood that. Oh, yeah, this might just be bytes, but like they're expecting single digits. They're not expecting multiple digits. So then if I did this, that's white. If I did this, that's red. Okay, okay, now I get it. But yeah, anyways, this is the what do you call it? This is the plugin. I can't remember what the plugin was called. I guess I'll just open up lazy to see. So you can see anytime it sees hash, even though here the hashes mean something else. The hash symbol is being used for something else. Anytime it sees a hash, it converts it to that color. And this is actually really convenient. Not necessarily in this case, but like in situations where I am actually dealing with colors, it's very convenient. I can't remember what the name is, so that's why I'm looking through my list of plugins. I mean, I did install this thing, right? So I could, would it be in the config list? Um, Plugins, Colorizer. The plugin is called Colorizer. That's the plugin that's doing this. Okay, all right. Moving on. Okay, the following is invalid. This defines the value of fruit.apple to be an integer. But then this treats fruit.apple like it's a table. And okay, you can't turn an integer into a table. Okay, all right. So these are certain rules that are being, created by the language itself, and whatever deserializer we have, that is probably going to be responsible for enforcing these rules. Okay, then moving lower. White space around the key is ignored. However, it's best practice to, yep, okay, all right. There was another example that we were looking at regarding white space. Also, does hyphen mean something here? I don't think hyphen means something here, does it? What happens if I do something like this? I guess let's just copy this, yank, paste, 1, 2. How did that happen? Okay, yeah, let's just say true. Okay, so it's not complaining here. Let's see what, right. That's just that doesn't mean anything. The hyphen one doesn't mean anything. Okay, then um all right, that's about spaces. Indentation is treated as indentation is treated treated as white space and ignored. You don't need to specify all the super tables if you don't want to. Defining a super table afterwards is okay. Uh, okay. You don't. Okay, I like that they've done this. I like that they've presented it in this way. So you don't need to do this, and then this, and then this in order to finally do this, which is why we were able to. What's a good example here? Which is why we were able to do dog.tater.man without explicitly defining, dog first, then tater, and then man. Um, yeah, you don't need these for this to work. Defining a super table afterwards is okay. I need to look into what a super table is exactly. Like, what are they referring to as a super table? Empty tables are allowed and simply have no key value pairs within them. Like keys, you cannot define a table more than once. Doing so is invalid. Okay, this is interesting because if I do it now, I actually have a TOML formatter slash kind of parser, which does actually complain about, a table being redefined, which does complain about the syntax, I should say. Um, let's say some name O2 equals whatever. If I save this, there we go. Conflicting keys. All right. Give me a second. Okay. All right. Back to this. Um, do not do this either. So it's like if you are defining a key as if you're defining apple as a key within the fruit table, or rather I should say if you are defining apple as a string, later on you shouldn't try to redefine it as a table. All right. Defining tables out of order is discouraged. All right, understandable. The top level table, also called the root table, starts at the beginning of the document and ends just before the first table header. Oh, okay, this is interesting. All right, all right. Unlike other tables, it is nameless and cannot be relocated. Dotted keys create a create and define a table for each key part before the last one. Any such table must have all its key value pairs defined under the current table header or in the root table. If defined before all headers, I'm lost. I'm lost. What's the example? Okay, this defines a table named fruit, yes, and it defines a table named fruit.apple. I thought it's just defining a table named apple, which is within fruit, but then I guess the way to specify that relationship is, saying fruit.apple. Okay. Um, this defines a table named fruit.apple.taste. Fruit and fruit.apple were already created. Wait, dotted keys create and define a table for each key part before the last one. For each key part before the last one. So dotted keys, I think what they're trying to say is that the entire this dotted key color is creating a table for each key part before the last one. This is the last one, and this has its value being defined here. And then this is before this. So this becomes a separate table. And then this fruit is before apple. So then this becomes a separate table as well. Um, okay, okay. Since tables cannot be defined more than once, redefining such tables using a table header is not allowed. Likewise, using dotted keys to redefine tables already in table form are not allowed. The table form can, however, be used to define subtables within tables defined via dotted keys. Okay, so if fruit has these keys, um, redefining apple, which is supposed to be a table, is apparently not allowed. Since tables can be defined more than once, redefining any such tables using a table header is not allowed. Okay, okay. So then this seems like a situation where you would then be using this as a shorthand. So if you want this to be, if you eventually want to create fruit.apple as a separate table anyways, then you might as well put apple.color within that. I wonder how that would work. Hold on. I'm curious about this. So we have fruit, and fruit doesn't have anything. Um, then fruit.apple, um, what are we doing now? Is it just color? Color equals, yeah. Um, does that work? Oh, this is not a valid value. Hold on. Yeah, let me just do this. So now this is giving conflicting keys. Okay, that's interesting. So we cannot define fruit first and then define fruit.apple. That's not going to work. Is that the case? Is that what's going on here? Let me try asking Gemini. Um, hey, I'm learning TOML. Why is this not valid TOML? So we have fruit, then we have fruit dot apple color equals red. Actually, that snippet is valid TOML if you feed the exact text into a standard TOML part. Really? Okay, hold on. Is this thing is the plugin or LSP client getting it wrong? No, there is an error. This is a comment, so and so, so and so. Um, okay, let's comment that out and see if it still compiles. Now it compiles. Oh, wait, let's do this. Oh, okay. It had to do with this. I had defined something up there earlier, and that's what was causing the mess. Yeah, we're good now. Fruit, apple, color. Oh, I also just wait, hold on. I also just realized something here. So apple was already declared as a table up there, and I guess here I was, you know, breaking one of the rules. Oh God. Okay, it just I think I just got it. I didn't notice it saying conflicting keys up there. I just noticed the red stuff, the red diagnostics. Okay, okay, that was yeah, that was my mistake. Yeah, let's get rid of that. Okay. All right. Dude, I was hoping to finish this today, which is why I named the stream Today We Graduating TOML, but I guess that's not going to happen. Um, where was I? So we have table. Okay, okay. What is this? Okay, all this is done. I guess, yeah, that's yeah, this is very important. Okay, since tables cannot be defined more than once, redefining such tables using a table header is not allowed. So that's why I was having the issue up there because I defined fruit. I created fruit dot table dot I think it was smooth. No, it was fruit dot apple dot smooth, meaning aside from the smooth key that was created, the apple table was created and the fruit table was created. But then I later on went and explicitly defined both fruit and fruit.apple. So that's why I was having that issue. All right. Inline table. Inline tables provide a more compact syntax for expressing tables. Wait, back up, back up. Hey, I'm learning. Actually, should I go back to that old thing? Oh, wait, let me. Okay, so this one is on me because I just noticed that early on in that same TOML code, I only gave you a small snippet of it. I had also written fruits dot or fruit.apple.smooth equals true. Give me a second here. All right, that one line completely changes the game for the TOML parser. When you introduce fruit.apple.smooth early on, you trigger a very specific rule regarding dotted keys and table definitions. Yeah, okay, all right, great. Um, hey, okay, so I'm glad that's solved. I am wondering though, what are super tables? While super table isn't an official term in the TOML documentation, it's a common mental model people use when learning the language. When people say super table, they usually mean a parent table or top level table that contains other tables nested inside it. In TOML, tables naturally form a hierarchy. Think of a super table as a folder, and the nested tables are subfolders inside it. Okay, all right. Right, getting back to this inline tables. What is an example of an inline table here? Contact.so-and-so, contact.work. The inline tables above are identical to the following standard table definitions. What are the inline tables here? So this is a table, which ends up as a dictionary. This is a table, also a dictionary. This is a table, also a dictionary. I find this interesting though. Um, type.name. This would not be valid JSON, I think. I'm not sure. I don't think this would be valid JSON. To be fair, I don't think they were claiming that this is JSON at all. I don't like it's not mentioned here. Okay, the equivalent of this would be name is that, point is that, animal is that. Let's take a look at animal, type.name. If we serialize this whole thing, type.name turns into type being a dictionary with a name key in it. And then that dictionary, the type dictionary, is within the animal dictionary. I don't get what the concept of inline tables is exactly. Okay, hold on. All right, moving on. Uh, all right, next doubt. I'm confused about what exactly inline tables are um, in TOML. Because it's saying here inline tables. Wait, okay, inline tables are fully defined within curly braces. Within the braces, zero or more comma separated values, comma separated key value pairs may appear. Key value pairs take the same form as key value pairs in standard tables. All value types are allowed, including inline tables. Okay, think of an inline table as TOML's version of a single line dictionary or JSON object. Up until now, you've been writing tables using the bracket syntax, which spreads the data across multiple lines. An inline table allows you to cram an entire table, keys and values onto a single line. I think I've hold on. I think I've seen an example of this. I need to wait. I've seen an example of this. There is an example that I can hold on. Scratch stuff. Um, what was it? Learning ESP32 Rust. ESP, let's go for 5. And in here, I think we have cargo TOML. I think these are inline tables. Yeah, these are inline tables. And then these inline tables have keys and values and other keys. The keys can also be arrays. Yeah, I think this is an example of inline tables. Holy shit, dude. This is like a separate concept from what I thought it was. Because after reading a little bit of this, I thought it's just talking about the same tables that we were learning about earlier. But no, this is a different thing. This is actually valid TOML syntax. I completely forgot that this is a thing. And it wouldn't have even occurred to me that that inline tables could be a thing within TOML unless I had remembered, you know, that within certain cargo.toml files, I've seen so and so thing happening. And I mean, to be fair, I am having this conversation with Gemini right now. So that also kind of, um, I don't know, turned on a light bulb in my head or whatever the saying is. Um, but yeah, Gemini is giving a good example of how the following, hold on, let's come here. Um, this this table can also be defined as, hold on, where is it? Here. This table can also be defined as this. I'm not going to save it right now, though. Let me give it a separate name. So these are two different ways of defining the table. This is an inline table. This is just a regular table. Okay, okay. And further down, we do have an actual example of inline tables. Okay, hell yeah, dude. You know what? I think that's going to be it for today's stream. I ended up starting the stream a little bit late. That was on me. But on the bright side, at the very least, I got to stream for an hour, so I'm happy about that. I also did a vlog today. I mainly only covered the GitHub workflow stuff, GitHub/Git workflow related stuff, and it was like very shortly before the stream that I recorded the vlog, and yeah, I got done recording a vlog as well, so I'm happy about that. As in addition to being able to stream today, I got to record a vlog as well, so I'm happy about that. I still need to cover more of the topics. Um, I have to talk about TOML, but I guess I'll talk about TOML after I've actually finished, learning TOML. Um, and then there's also the gaming on Linux thing that I have to talk about. I'm going to be talking about these two things in separate vlogs, or in the next vlog. Maybe I'll squeeze both of them into the next vlog. I don't know. I don't want to make them their own separate topics, though. I don't see anything wrong with that because I'm going to play Metro 2033 Redux later on. I'm also going to play Stardew Valley later on. So I'm still going to be able to, talk about it. Um, but I mean, in terms of productivity, TOML, I definitely want to talk about. TOML in the next vlog. I feel like I'm gonna have a bunch to say as well about TOML. Because dude, TOML is used in like I've seen it used in much more than just Rust cargo TOML files. I've also seen it used in like in PyProject TOML files. I've seen it used as I forgot if that was meant to be TOML or YAML. I can't remember at this point, but Gemini was telling me that there are situations where you have, let's say, parameters that need to be defined for a certain model, and or maybe you have training parameters or something like that that you want to define. If you try to define it using JSON, the syntax is very different. You have to like write out the entire JSON and get the entire thing right. It's not meant to be necessarily written from scratch by humans, because if you make a mistake there, then your deserialization is gonna go to shit. Um, Instead, you could use TOML, and TOML has a very straightforward. Hold on. Oh God. Okay, I made that mistake again. Um, Wait, I can do it from here. Instead, you could, what was I? Oh, yeah. Instead, you could just, write TOML, which has a much, much more simpler syntax, especially if you're not doing something incredibly complex and, you have multi-level structured data and stuff like that. If you're not doing stuff, but to be fair, even if you are doing stuff like that, TOML is a lot more intuitive to write by hand than JSON. And this is coming from someone who has used JSON for more than a decade. I use JSON all the time. Back when I was doing C# stuff, I used JSON a whole lot in Python. I've used it a little bit in Rust as well. Take it from me, it is not necessarily meant to be written by hand. It's meant to be just like an intermediate language that one program writes and another program decodes. One program encodes and another program decodes. But yeah, okay. I forgot I was supposed to end the stream. So yeah, that's going to be it for today's stream. I don't know, maybe I might record another vlog tomorrow. I don't want it to be like a daily vlogs kind of thing. So, I mean, I've recorded this vlog today. Maybe the next vlog I can record it in like a day or two or something. Today I do have to spend some time setting up the upload of this vlog. Fortunately, there's nothing to stitch together today, so I can directly upload the thing. I just need to create captions and stuff like that, and we should be good to go. But yeah, dude. Okay, that's gonna be it for today's stream. I hope you guys have a nice day, and I'll see you all next time. Peace.